So again, we want to welcome everyone to tonight's webinar on our summer 2022 review and our September 5th flash flood review. My name is Joe Deli Carpini. I'm the Science and Operations Officer, and with me tonight is Rodney Chai, one of our meteorologists and frequent contributor to our webinars. So I'm going to get us started with the review of summer, and then Rodney will come in and he will go over the September 5th flash flood event. And just a reminder, if you have any questions, go ahead and use the chat box as always, and we will answer those at the end. So in short, I think most people will probably remember this summer. It actually started off relatively cool, if you remember, in May, in April and May, and even into June. So the first part of meteorological summer in June, there was actually a relatively cool start. It was a little bit wet initially, but then drought conditions really emerged and worsened right around the 4th of July, a little bit after that, and really we had some oppressive heat, especially in the later part of July and early August. And really, so far, it's been one of the quietest severe weather seasons we've had in some time. I've been at the office for about 25 years, and I would say this is probably definitely within the top 5 of quietest severe weather seasons. Really haven't issued many warnings or had many severe weather events. The pattern did start to turn somewhat active, though, in later August, but really haven't had a widespread soaking rainfall. We've had, some showers and thunderstorms move through much of the area, bringing some beneficial rains, most notably August 23rd, August 26th, and even September 5th that Rodney will talk about tonight. So we've had some definitely, you can see the lawns greening up a bit as the rain has fallen. Now the sun angle is also getting lower, so the evaporation is decreasing. So better news hopefully ahead here in the next few weeks. We'll at least see some showers and storms moving through, but I think an overall wet pattern is really not on the cards anytime soon. So we'll get into that and in our weather briefing a little bit later. So we get a lot of questions, why do we see so much heat and humidity there late July and August? And when we talk about heat waves, we talk about blocking high pressure, which circulates hot and humid air kind of wherever it is. And this high pressure in the summer, we call it, a summertime ridge. It can be off the East Coast. That's known as the Bermuda High. It can be over the Plain States or even over the Rockies. So it varies. It's called a subtropical ridge. And in the wintertime, it's usually closer to the coast of Africa. And then in summertime, it migrates more to the Western Atlantic near Bermuda, but really can be located anywhere. So this year was a little bit different. Normally, we kind of think of the Bermuda High off the East Coast, but it really wasn't. And this little animation will kind of show us at the Jetstream level kind of where that ridge was. You can see by the winds as this animates that there's a big ridge of high pressure over the Rockies. And we were actually, for a time in a little bit of a trough, which usually means cool air, but there was so much warm air, it actually lifted up to the north of the United States into Canada and came back down across the Great Lakes. So this was just really a big heat pump, and you can see the circulation around it eventually settled around the Plain States, eventually migrated into the east. But for much of the summer, and this is just a sample of the hot and humid weather in late August, you can see it really was dominant across the Rockies and eventually migrated here to the Plain States. I'll let this play through again. So if I were to look at this map and say, where's the heat, I'd definitely say in the plains, not so much here in the Northeast with a trough, but really just made its way right from the west into the eastern United States. And like I said, most of the time we see the circulation more off the coast as opposed to over the Rockies and the plains. So a little bit different pattern this year, but certainly one that can produce heat and humidity too. So let's look at some of the summer temperature trends at our longer-term climate sites. I think you're familiar with all of them. We'll start off with Boston at Logan Airport. The hottest day for the summer, and this is just a graph, you can see all the daily highs and lows by the blue bars. So the bottom of the bar is the low temperature, the top of the bar is the high temperature. And then what we're looking at in the shading is this kind of light brown shading is the normal or average temperature range. And then we have our record maxes in the red curve and the record lows in the blue curve. And you can see we're got a little close there toward the end of June with some record cool temperatures in the low 50s. But for the most part, we were in the normal range or even above, and you can see what really sticks out is the extended period of heat and humidity just after July 18th all the way through about August 8th. We had a record high as well, but you can see really for the most part we're at or above normal for the entire summer in Boston, and this includes the months of June, July, and August, which is meteorological summer. So hottest day was 100 degrees on July 24th. I think you can see that right there. There were 21 days of 90 plus temperatures in Boston, and the average is 13. So we were above normal in that regard for Boston. Now, if we look at Providence, a similar pattern there. You can see cooler weather again toward the 20th of June, roughly. Not quite in record low territory, but really everything near or above average. And again, you can see that stretch from just after July 18th all the way through about August 8th, where we're well above average. And the hottest day was 98 degrees on July 24th, and we also did it again on August 9th. I don't think it's plotted right there. Providence had 16 days of 90 plus temperatures, and the average there was a couple fewer than Boston at 11. So above average as far as 90-degree plus temperatures for the summer in Providence. So these are the coastal locations. When we go inland, even more of a big signal for warmth. This is at Bradley International in Windsor Locks, which is the Hartford area in Connecticut. And again, similar trend. We've got the little bit of cooler weather toward the end of June, and then we pretty much warm for the duration of the summer with, again, our stretch of hottest weather from about July 18th to August 8th. Hottest day was 97 degrees on July 20th. And there were 26 days of 90 plus temperatures, and the average is 17, so really well above normal when you go into the interior part of southern New England. And I think you'll see the same trend here at Worcester, not quite as strong, but it's an elevated site, so it's usually a little bit cooler than Hartford, which is in a valley location. But similar trend you can see here. The hottest day was 93 degrees on August 6th and 7th, right there. And there were 8 days of 90 plus temperatures. The average is only 3, so almost triple the average number of 90-degree days for Worcester. So you can see the theme was definitely above average temperatures across the board and above average the number of 90-degree days as well. So there was the warmest 22-day stretch on record, and I thank Rodney for looking this up. As you can see here, these are ranks of 22-day stretches from July 19th through August 9th. So we're trying to capture that stretch of the hottest weather that we experienced. And yeah, it was the warmest on record. You can see for Boston, it was a good couple of degrees above the previous record set in 1980. For Providence, it was set just a couple years ago in 2020. Hartford was just beat it out for 2020 as well. And for Worcester, actually beat 1949 by nearly a degree. So that's pretty impressive stat for Worcester. But the warmest 22-day stretch. Again, we're just sampling a random 22-day period, but it's just interesting to note that this was really the peak of the heat and humidity, and it certainly was unusual. So now let's take a look at some of the rainfall trends, and I don't think there'll be any surprises here. We didn't add the total for Boston, but that's okay. So the total is actually here at the end. So the green curve is the actual total precipitation, and the brown line here is the average or the normal. So you can see earlier in the year, as we came out of winter, we were actually near or even a little bit above normal. And then as we got into spring, into May, we started to get a little more of a departure below average. And then it really took off as we got into June and July and August. It's almost a flat line here, almost no rain at all from July 1st to the end of August. And the total was just over about 17 inches. And the average is not 10. It's actually up here at about 27 inches. So we're almost about a 10 inch departure from normal. So that was pretty significant. Now we've made up a little bit since then, but we're still averaging below normal. And for Providence, a similar trend. Again, this is representative of the coastal sites, near or above average as we headed into May. And then we started to see the departures really go, not so much into June in Providence. There were a number of showers and thunderstorms that affected Rhode Island and southeast Massachusetts during this time. So really wasn't too bad. But July, notice how it almost flatlines from July 1st, almost into the middle, past the middle of August. The total was closer to about 24 inches. This is actually for the year, with the normal would be about 31. So about 7 inches for the year, but much of that departure was over the summer. Across the interior, not as quite a significant departure as you see here. Again, at or above normal into the spring, even into most of June. Number of showers and thunderstorms affected the interior parts of New England, so really wasn't much of a departure. But you can see even here, less so than the coastal areas, but the total by the end of August was about 27 inches. The average is about 31. So roughly 4, maybe 5 inches below normal for the Hartford area. And a similar signal for Worcester, too. You can see the total was up around 27 inches. The average should be about 32. So running, less of a departure in the interior. Definitely the coastal areas, eastern Massachusetts, Rhode Island, Cape Cod, the islands, the South Coast had the greatest rainfall departures over the summer. And you can see this on the drought monitor pretty clearly. I don't think this is any surprise either. As we got into the end of May, some of the dry conditions were beginning to emerge. We had some areas of the D1 category of moderate drought surrounded by an area of just abnormally dry, which we call D0, and actually fairly normal across the east slopes of the Berkshires, Connecticut River Valley areas into northern Connecticut. And you can see by the end of August, much of the area was in extreme to even extreme drought in the red, with the severe drought here in the orange, pretty much all of the area. Now we've recovered since then, and we'll get into that a little bit later, thanks to more frequent showers and thunderstorms. So here's just a look, at one graphic. Here's the total precipitation for the summer from June, July, and August. You can see good corridor of showers and thunderstorms, as I mentioned, across Connecticut, Rhode Island, and southeast Massachusetts. So these areas actually had pretty plentiful rainfall and less of an issue with drought conditions, even in parts of the Pioneer Connecticut Valley here. The greatest departures, northeast Massachusetts into metro Boston, Cape Cod and the islands, the south coastal areas, even down across coastal Connecticut, and even into the Litchfield Hills, parts of the Hudson Valley in New York, had the least amount of rainfall. I don't think that's any surprise if your lawn or garden certainly took a hit this summer, especially for these areas that were in red, where we had the least amount of rainfall. And just looking at it from a departure standpoint shows the same signal. There were departures below average in the green, 1 to 2 inches, but not as much as 5 to 6 inches plus in some of these darker red shadings across the region. So this again encompasses June, July, and August. So some of the late August rainfall is incorporated into that as well. And then just looking at the month of August, you can see here's the wet signal, Plymouth County especially, but parts of even Bristol County. One of our hydrologist who lives in Rehoboth had 7 inches of rain in one day from some thunderstorms. Parts of eastern northeast Connecticut as well. So this was kind of the area where the showers and storms tracked in August. You could see definitely less along the Route 2 corridor, Cape and Islands, and parts of western New England were the dry spots. So many locations, communities enacted water bans. This is an example from Attleboro. You can see the Hoppin Hill Reservoir in July is almost down to nothing. And many communities still have mandatory water bans in place despite a little bit of recent rainfall. It really hasn't done much for the larger, for the water supply, as opposed to more short-term relief, thinking things like lawns and gardens and things like that. So many areas still have the water ban, so it's important to follow those as we head into the fall here. And your local town or city can have more information on that on their websites. So as we go into fall, what's going to happen? Well, it doesn't look like at least a wet pattern overall. Still looking at above average temperatures as we head into November. Pretty good chances of that here in the Northeast. Really no signal saying it's going to be wetter or drier than normal. So there's definitely a dry signal kind of in the middle portion of the country, but really nothing here. Hopefully we can get at least some showers and thunderstorms. The tropics can always contribute too. Hopefully it's not a full-fledged hurricane, but maybe some remnants that just bring some tropical moisture into the area to help us out a little bit. But really nothing on the kind of the global scale to say it's going to be wetter or drier than average for the meteorological fall. And in the winter, I know many people are interested in the winter outlook. Right now, that this is kind of following the La Nina pattern, which we're expecting La Nina to persist. We had it last winter, and we should see it again for much of this winter. So gives us above average temperatures, much of the East Coast, with, again, equal chances. Really nothing to say above or below average. Tends to favor the Great Lakes, parts of the northern Rockies, and there's definitely a signal for below average precipitation across the southern tier of states. That's pretty classic when we get into the La Nina pattern. So for us, last year we were kind of near average snowfall. We just have to see if the cold air times with the precipitation and makes enough snow. So we can do pretty well in some La Nina years, but others we're pretty much cold and dry. So we'll kind of have to see how it goes. And when we get to our winter outlook webinar, you'll see it's really our predictability is more in the order of weeks instead of months. So we know kind of maybe 2 to 3 weeks ahead of time, we can kind of see the pattern unfolding. And most of our winter tends to be late January, February timeframe. So stay tuned for that one. And as I mentioned, the La Nina is forecast to persist through the winter of 2022 and 23. So there are some signs, and you can see here on the right, these are all the model forecasts. La Nina is kind of below the curve, El Nino is above, and you can see the majority. Might be a little hard to see, but this is kind of going to the end of the year. Keep us well into La Nina, but then things start to trend a little bit more neutral as we get toward March and April. So it's possible we could be losing the La Nina toward the end of the winter, but definitely looks like for next meteorological spring of 2023, the La Nina will be going away. So we will see if that continues as well. But we might be turning the page a little bit with our pattern, at least on the shorter term. Here's a look at the rainfall from August 22nd to 24th, and we will have a more in-depth webinar on this, but you can see a good corridor of 4 to 5+ inch rainfall across northern Connecticut, northern Rhode Island, southeast Massachusetts, and especially Plymouth County, where some areas picked up over 7 inches of rain. So this was definitely some beneficial rainfall, widespread rainfall. Even areas a little bit farther to the north picked up an inch, where you see kind of the darker green shading. So we'll see. We've got some more showers and storms on tap for tomorrow, so maybe we'll get a little more rainfall out of that as well, and at least get some rain and not have a continued stretch of dry and hot weather. So with that, that's a quick look at the summer. Now I'll pass it over to Rodney, and he'll take a look at the flooding and the rainfall from September 5th and 6th. So Rodney, it's all yours.
Okay, thank you so much, Joe. Let's talk about the flooding and rainfall that we saw actually just a week ago. Some places saw flash flooding like Providence, and you can see in this map here, really I think the Providence to Cranston corridor saw the jackpot of the rainfall, with some places almost a foot of rain. And unfortunately that coincided with the Labor Day travel, and maybe some of you might have been affected. I-95 was closed just south of downtown Providence for a few hours because of there was just too much rain falling over the same area over a short period of time. So, but for the most part, a lot of vast chunk of real estate saw widespread soaking rain outside of that burst of rain Monday afternoon. Areas like Cape Ann and the immediate eastern Massachusetts coast towards Cape Cod and the islands missed out on the rain. And here's another look with so the color shading, that's the radar estimated rainfall, and the numbers that you see on the screen, those are the reported rainfall, and these are kind of like a mix of like official rainfall reports and unofficial rainfall reports, but it kind of give you an idea of the spread. And but you can see that like Providence, the radar estimated like close to 10 inches of rain, and people in the vicinity reported over 9 inches of rain. So that's pretty accurate. But you can see really where the blue shading and purple shading, that's kind of over 4 inches of rain, and then the red color, that's 2 inch plus, and the green is less than 1 inch of rain. And yeah, this is just south of downtown Providence. Then on I-95, you can see that the cars, unfortunately, they were caught in the waters, flood waters. Thankfully, no injuries or fatalities. But you can see how the traffic was held up southbound on I-95. So, and that's why we tell people, turn around, don't drown. Even if you inconvenience you for maybe 10-15 minutes, can potentially save your life. So here's the meteorological overview. So heavy rain developed along a slow-moving front, resulting in widespread rainfall and pockets of street flooding. The radar estimated rainfall was probably a little overdone, and we have different kinds of estimate, and the dual pole actually most accurately matched the observed rainfall. And this is a classic, what we call a warm rain process. And because if you look at an atmospheric sounding, we have basically a fully saturated sounding up to 15,000 feet. And the high resolution ensemble forecast and the probability match mean, the PMM forecast, did a great job taking out the possible areas of heavy rainfall. And the Providence metro area experienced considerable flash flooding thanks to the stored frontal boundary with I-95 shut down in both directions. And so, besides the stored frontal boundary, the temperatures actually were a little warmer than the forecast, what was forecasted by the high resolution guidance, especially south, areas south of that stored boundary, so areas like southeast Massachusetts, southern Rhode Island. And when that happens, when you have the atmosphere is a little more warmer than expected, this leads to better instability, and it results in a sharper thermal and instability gradient. And the atmosphere really likes to thrive on this kind of gradient. And this really helped to boost the rainfall rates in and around the Providence, Cranston area. And some of you might remember, actually, the New York City office actually issued a tornado warning in Fairfield County, Connecticut. And there were areas to the south and west that were a little further into the warm sector. So, and there was a little bit of spin in the atmosphere. So, and because of the low cloud heights, it wouldn't take much to cause a brief spin up. So we were actually for a few hours that afternoon, I worked that afternoon on Labor Day, and we were a little concerned about tornadic potential, but thankfully nothing tornadic happened. So here's the radar loop. You can see that that line, the red shading representing heavier rainfall rates, and you can see kind of really started in the Sturbridge, Massachusetts area, and then kind of sagged southward with that frontal boundary, which eventually stopped just south of Providence. So that led to that flash flooding in Providence. And I alluded to the probability match mean product from the high resolution ensemble forecast guidance, and you can see, that proper red shading, that's, talking about 3 inches of rainfall or more for in a 3-hour period. So that's 1 inch per hour rainfall rate. And look at where it is shaded. It's Providence. And so the probability match mean product actually did a great job to highlight the potential area for flash flooding. So that's a very, very useful product. The HREF product is freely available to the public. So if you like the HREF, highly recommend checking out the probability match mean product. It's much more skillful mean than, say, the normal mean, because it captures the more extreme members instead of just smoothing everything out. And here is the again really highlighting the potential for heavy rainfall really from and that's 3 hours later, and it makes sense because as the cold front slowly sags to the south, it brings with it the heavy rainfall potential further to the south. So in this case, we're talking about more like coastal Connecticut into Washington County, Rhode Island. So and thankfully by the time the frontal boundary sag to the south, we kind of lost the best diurnal heating, best daytime heating. So those places still saw heavy rainfall rate, but it was really less of a flash flood threat, and more of like a beneficial soaking rainfall. And here, taking a look at the probability match mean, taking out the 24 hours, and you can see again the area where it's highlighted, 5 to 7 inches of rain. And of course, like Providence to Cranston did better than 7 inches, but again, this product highlighted the heavy rain threat and of course the flash flood threat as well. Not all places are going to see flash flooding, but it's very useful, especially for us for our forecasters, because we want to, provide the best possible decision support services to our emergency management partners. So we, in our briefing packages, we did tell them, there's a likelihood for flash flooding, maybe in the, somewhere in the Providence area, and it did come into fruition. And so, given the flood threat, we issued a flood watch. So again, kind of like going back to the difference between a watch and a warning. Watch is the ingredients are there for something to happen, and a warning is it is happening, and it's time to take immediate action. And so, if you take a screenshot of the visible satellite imagery, so lots of clouds, but look where it's sunny, Nantucket. So it's not that often that Nantucket actually has the best weather in southern New England, but that was one of those days, because you have the wind from the southeast, and actually that's where the drier air was. So the dew point over Nantucket was actually in the 50s, but it was like well into the 60s for the inland. And then north of the frontal boundary, you have the cool northeast flow. So those of you who live on Cape Ann, I mean, you're pretty much stuck in the clouds, the cool conditions the whole day, but you kind of miss out on the rain from the storm boundary for the south. So that's kind of like it's pretty crazy to think of blue skies when there was considerable flash flooding, in the capital of Rhode Island. So I alluded to that how this is a warm rain process, and we have basically like deep warm cloud depth. In this case, this was actually the observed sounding from Albany. So when they release the weather balloon to the sky, and it measures the atmosphere for you. So you can see the green line, the red line. It's basically kind of like close to each other, all the way up to almost like 12 kilometers. And basically the green line is the dew point temperature, the red line is the air temperature. And when those lines are together, the dew point is pretty similar to the air temperature. So the atmosphere is, it's almost fully saturated, it's loaded. So at that point, you just need a triggering mechanism to unload the moisture from the atmosphere. And that trigger was the stationary front and the marginal daytime heating that helped to unload the moisture. And unfortunately, Providence bore the brunt of it. So this was the Weather Prediction Center excessive rainfall outlook, and it's not all that common for us to see, a moderate risk for excessive rainfall. So in this case, the WPC issued this level 3 of 4 excessive rainfall outlook. So you can see the area that's in red, that was pretty much the area that got hit pretty hard by the heavy rain and in some locations flash flooding. And this was the mesoscale discussion. So WPC, during times of significant weather events, as the events unfold, they will issue updated mesoscale discussion to kind of like it's a public product you can access on the WPC website. And sometimes we will tweet it out as well, and to kind of like, give you an idea of how the weather event is going to unfold for the next few hours based on their analysis of the immediate environment. So in this case, you can see that that stored frontal boundary, you can see that the red and the blue on either side of that line. So that's a stored stationary front. And then you can see the L is the center of low pressure. So basically you have heavy rain in the vicinity of that stationary front. And here is on the left-hand side, you have the surface analysis, again showing the surface front. And on the right-hand side, you can see the radar reflectivity, and with some reports overlaid on it, so the person icon that's reports of like flash flooding, and the green polygon that's your flash flood warning. And as I said earlier, the temperatures kind of outperform a little bit, especially areas to the south. And you can see, and this is the surface-based cape or instability. So, if you're not familiar with the idea of cape, basically, if you have like solar heating of the atmosphere, you get instability. So, that's why on days when you have like severe thunderstorms, the potential for severe thunderstorms, it's actually not a good thing to see the break in the clouds, because the sun would kind of juice up the atmosphere for it to produce more stronger thunderstorms. So in this case, you can see how the contour lines, we're kind of like on the edge. So like Providence, when you kind of see this kind of gradient, that's where like storms kind of like to really outperform. So, unsurprisingly, the area of Northeast Connecticut to Rhode Island saw the brunt of the flash flooding. And further to the south and west, where you have more instability, that was when we saw the possible brief spin up in Fairfax County, Connecticut. So here's another look of the flash flood warning that we issued. I just wanted to point out that there's a considerable tag to it. And some of you might remember, if you're in the vicinity, your phone was actually going off. Hopefully it did go off, because having the considerable tag to the flash flood warning would activate the wireless emergency alert. So here's the one of the more recently developed radar products. And so the whole idea is that, if the radar can estimate the rainfall, it can also estimate the potential for flash flooding based on the local climatology and the local soil, and in this case, the blue, when you see the blue and purple pixels, that, if you see a lot of them, that's kind of like a signal to the forecaster who's in charge of the hydro situation, might need to consider either a flood warning or a flash flood warning. So in this case, we went with a flash flood warning, and it was the right decision. And so, you might have heard some people talking about, how historic is this flash flood event. And this is the, again, the same website, but this showing you the return interval. Now don't take the number verbatim, but it kind of it provides a sense of, just how extreme this flash flood event was. So you can see the purple color, that's kind of like 75-year, 100-year, event. But again, don't take the numbers verbatim. But it again goes to show you, how hard the rain was coming down. So, and I think we'll address that, I guess, in the Q&A section. I saw some questions about, it's like we only have our 4 climate sites, but if the heavy rain, the convective rain did not fall over the climate site, would this really capture the how much rain fell? And this is kind of like a partial answer to that question. So what I'm showing you here is basically different depictions of estimated rainfall. So basically how this works is that, from climatology, when I put on my climatologist hat, we have so many data points, we have so many observations. We try to take as many reports as we possibly can within our constraints. But then there's an algorithm to basically kind of smooth out all this observation and to take out bad data. So in this case, what on the left-hand side, that's the, the estimated rainfall from the Midwestern Regional Climate Center. So you notice this is kind of smoothed out. It didn't really show the bullseye over Providence to Cranston area, but it gives you the idea, of what happened on the first week of September. Because ultimately, this data is used to make decisions like, and this is above my pay grade, like to decide, what kind of drought level should Massachusetts be in, should Connecticut be in, and they take this kind of data to help them make a decision, because ultimately you want to, it's not helpful if you have too many data points and too much noise. So, but this is kind of like the an option to get good climate data. So, and then on the right hand side you can see similar idea but different color scale. But the idea here is that from Connecticut into Rhode Island and parts of southern Mass, there's not a lot of rainfall, but much less towards Route 2 corridor and definitely Cape Cod and the island. So the idea is that. And here's basically an outdated drought monitor outlook. This is the previous one for the improvement. So that you can see the red, that's level 3 drought, and then that orange, that's level 2 drought. And I want to show you this because the dots that you see are the stream flow gauges. If you see this, the gauge is green, that's normal stream flow, and the blues are the above normal. So you can see after the recent rain, most of the gauges are now actually at normal or above normal stream flow. And groundwater is going to take a while longer because it takes time for the water to seep through. And some of the rain kind of, was just a runoff because it fell so quickly. And they just flow straight into the waterways. They didn't really soak into the ground. So, but nonetheless, this is a step in the right direction. It's good to see the stream flow gauges trend normal to above normal. And so, like I said, on the right-hand side, that's the outdated drought monitor. And then on the left-hand side, that's the latest one. You can see, most places have seen an improvement, maybe with the exception of North Central Mass and Cape Cod and the islands. But, hopefully, fingers crossed, to continue to see an improvement in the drought conditions. So, as Joe actually presented on something very similar, but this actually just included the rainfall from the last few days, and you can see Boston, not so much. I mean, it's on the immediate coast. This is at Logan, and you can see from the rainfall map, the immediate coast actually missed out on quite a bit of rain that the inland areas got. So. But still, you can see the deficit being chipped away, especially in the last few weeks for Boston. Hartford, Connecticut, you can see, the deficit was wiped out, and from the recent rain, and pretty much you go from below normal to near normal, so that's pretty good. Providence, you can see the big jump. That's Providence, the climate site is at TF Green Airport actually, so that's away south of downtown Providence, but still, it picked up on quite a bit of rainfall, so the deficit is being reduced here. And for Worcester, again, trending to near normal with the recent rainfall. And so, taking a look at the latest Hurricane Center 5-day outlook, it's been a really quiet start to the hurricane season. So, and it's kind of like, you know, we'll see what happens, because the forecast was for above normal hurricane season, but there's still a lot of hurricane season to go through. So we'll stay tuned. And so that's the end of the presentation. I guess we'll pass it back to Joe.
All right, thanks, Rodney. And we'll go through some questions at this point. So we'll start. Let's see. Hopefully we get to them all. Let's see. Carrie's got a question about allergens. A little outside of what we do, Carrie. You may have to check with the website. And Rodney, do you remember what it is offhand for allergens? Because that's not really something we get into regarding drier versus wetter summers. But
No.
yeah, Carrie, if you drop me an email, I can get you the site. There is a site that actually follows that. It might have a little more information on that. So sorry, but that's a little outside of what we do. Okay, Jonathan's got a question. Given the typical Rossby wave pattern, how unusual is it to have two simultaneous widespread heat waves over North America and Europe? Ooh, Rodney, you want to tackle that one? You're the global guy.
Yeah, this is not an easy question to answer. First I would say that I'm not entirely sure about the impact of the Rossby waves on this anomalous summer. But I would say, I'm going to say this summer has been, more research still has to be done, but from what I've read, this summer has been pretty historic. Not just here, like in the US, but Europe, places like London, hitting 40 Celsius or 163 Fahrenheit or higher. You're talking about a place where the normal high should be 70 degrees. And it's not just Europe, but across much of Asia, and North America as well. In fact, there's a heat wave ongoing right now in the West. And so, I would say that it's been a pretty historic summer in terms of like the anomalous temperatures way above average. And in a way, we kind of got lucky here in southern New England, because we didn't really get into the heat until after the 4th of July, and we have a cool start to the summer. But of course, that heat has to go somewhere, because the heat was building up across much of the southern U.S. and then has to come here eventually. So then we got into the brutal stretch of 6 weeks, I think. And then the heat that kind of made the drought worse. It's kind of like a positive feedback loop. And so, yeah, it was, I think more, I wouldn't be surprised, though. I think there will be a lot of research coming out in the next year about this historic summer, the historic heat waves just across the world.
Yeah, I agree. So hopefully we'll get the climate folks on this one, Rodney, and they can give us a good explanation. But yeah, I think there will be a review of this. So stay tuned, Jonathan. Question there was from Jeffrey. Rodney, looks like you answered it, but I'll just mention it. How does the rainfall trend compare with last summer? And if you remember, last summer was definitely wetter than normal. And we kept, got it wetter as kind of the summer went on. So there were no issues really with, any significant drought or deficits last year. So wet summer one year, a dry summer the next. From Valerie, we seem to miss much of the rain that falls elsewhere inland here on Cape Ann. Why would that be? And that's a typical summertime pattern. Once you get east of, like, say, Worcester County, areas in eastern Massachusetts, Rhode Island, any thunderstorms that come across tend to weaken because of the stability of the ocean. And so it actually weakens the storms typically as they head east from Worcester County. So a lot of areas to the east tend to miss out on the rainfall. But this year, the corridor just kind of set up much of the time, northern Connecticut, Rhode Island, southeast Massachusetts. That's due to, kind of where the fronts end up, where the best kind of convergences for the moisture, things that happen on a really small scale that can be tough to predict, even a few days in advance or weeks in advance. So every year there seems to be a corridor that does pretty well with rainfall. I think, Rodney, most of the time it ends up being up near Route 2, like northern Mass and in the interior areas. But yeah, this year it just shifted a little bit farther south. So, the Mass Pike corridor and points north really missed out on most of the rainfall. It was just a little bit farther to the south. Let's see, from Ethan, with most of our summer rain coming from convective storms, are the totals from these climate sites necessarily representative of other areas around them? Yeah, they are. They have a very long period of record, some going to the late 1800s or early 1900s. So today we have, additional rainfall networks. We have our co-op observers. We have hundreds of CocoRa's observers who are volunteer rainfall observers. So we have a lot of additional data now we can pull into the different rainfall analysis that Rodney was showing. So it makes it a lot better. We're not just using 4 or 5 points here in southern New England. We're using a lot of data, hundreds of data points now. So it's just the climate records are fairly short for these other stations. I can tell you for CocoRa's, we started that in 2008 to 2009. So it's less than 20 years there. But the longer term sites have a good period of record. So that's why we kind of use those as the standard. But you're right, it's hit and miss. So the more observers we have, the more likely we're able to get it. So let's see. Rodney, I'll toss this next one to you from Ethan. It actually talks about the winter, but with how warm the subtropics and northern waters have been, does that increase the likelihood of above average water temperatures off the northeast coast persisting? And if so, would that make nor'easters and winter storms more potent? So that's a winter question. You can have that one.
Sure. Thank you, Joe. Yeah, Ethan, no, thank you for that question. So, we have been in a La Nina pattern for quite some time. So, I think my guess is that, it'd be interesting to see if we can get into El Nino, because that usually favors a stormier pattern. And you really just need the air to be cold enough to generate snow. So it's a little too premature to look at the buoy data and look at the history, the climatology. But theoretically, yeah. If you have a warmer ocean, the atmosphere is likely going to be more fused up to produce storms. And of course, you would need to have the right storm track as well. And this is why it remains to be seen how long we're going to be in, how much longer we will be in La Nina, which tends to, by the way, favor kind of like a cooler, dry winter pattern for the northeast. And then El Nino would be kind of on the flip side. You kind of have a stormier pattern, although milder winter. But like I say, you just need the cold air to be at the right place at the right time to get a good storm. So, I would say the short answer is, if the sea surface temperature, when I say above normal, they'll still drop down to the 40s by the end of the year. So, but I would say that if the sea surface temperature is maybe like 1 or 2 degrees warmer than average, it could potentially lead to more intense storms. Then the question would be, would there be enough cold air for it to force snow? Would it be kind of like a rain towards the coast? So I think really the jury is still out on what we can expect this winter. So this is just my best guesstimate for now, Joe.
Okay, that sounds good, Rodney. Thanks. Let's see, a question from Tom might be a little bit outside of our expertise, but maybe Rodney, you would, since you're more of a expert on this. Aside from La Nina, could lowering atmospheric SO2 contribute to our recent hot summers? I know there's a lot of factors that go into it. That could be one of them. But Rodney, any comment on that?
Joe, you say SO2?
Correct. Yes.
Oh wow. Okay. So I have not seen anything that suggests the sulfur dioxide might have played a role. If anything, just based off chemistry, if you have more sulfur dioxide in the atmosphere, it tends to block out the sunlight and leads to a cooler atmosphere. So if you think about like a volcanic eruption, if you have a big one, then you could have like SO2 in the atmosphere kind of. And there have been times in history, the recent one being 1812, the Krakatau volcano in Indonesia. It erupted and then it led to cool summers for a couple of years around the world. But no, I've not seen anything that suggests SO2 might have played a role in the climate. But that's historical precedence. That's enough of a major volcanic eruption can lead to a cooler weather around the world.
All right. Thanks, Rodney. Yeah, we don't get too much into that in our area, but our field really. But good to know. All right, from Jeffrey, is drought classification based on rainfall only, or does it include reservoir levels? Actually includes a number of things. So the one thing we supply to each of the states for their decisions is the rainfall, obviously. They look at a number of things. Yes, the reservoir levels, both large and small. So the smaller ones that feed certain towns, and then the larger ones, like say the Quabbin Reservoir in Massachusetts. They look at all different indicators. A lot of longer term indicators. So you're not going to see us jump into like a D3 out of nowhere. You're going to eventually go to D1, D2, D3. Normally you'll change one class at a time. And even coming out of it, it'll go that way too, quite often. So it includes a lot of different factors. There's a number of them that they use, a lot of indices that take into account even things like fire weather potential, like brush fires. But a lot of longer term indicators are used in addition to rainfall only. But rainfall certainly is a driver for a lot of it. All right. Question on why is the tropical season so quiet? Rodney, I'll give you that one.
Yeah, sure, Joe. Yeah, it's been really, I think, how quiet the tropical season has been. I think it has caught, most of us by surprise. I mean, the NHC, I think up to a month ago, they were still pretty confident of an above average hurricane season. Now, this is not to say it's not possible, but the window is closing, and the longer we don't get a storm. I mean, granted, we did have two hurricanes that were pretty much out to sea in the last week, and one way you can follow how the tropical season has unfolded is through something called the ACE, accumulated cyclone energy, and that ACE that actually kind of really the two hurricanes that we saw has really helped the ACE to catch up, in terms of deficit, but thankfully it has not made any landfall or affected any communities. So, and the big reason for that is really because, at least for our area, we have been persistently in that the upper level of trophiness pattern. So when that happens, you have to dip in the jet stream, and hurricanes or tropical cyclones, even though they get a lot of attention, they are very small in the grand scheme of things, at least from an atmospheric standpoint. So when you have this, like upper level pattern, especially the trough over the East Coast, that would really help to kick it out to sea. So you really kind of need to be like, you need to almost have like a ridging pattern over much of the East Coast for the tropical cyclone to be kind of like drawn inland at least towards the eastern seaboard. So it remains to be seen, I guess, what there's still like 2 months left for the tropical season, so a lot can happen in this 2 months. So I guess we'll have to see whether the tropical season lives up to its potential. Joe.
All right. Thanks, Rodney. Let's see. Moving on. We got a few more questions, and then we'll get to our weather briefing. From John, do extended periods of dry weather promote higher daily temperatures? Yeah, it can, because think about it. You have, especially this year, you have less You have a lot drier air right at the lower levels, less evaporation, less green. People's lawns dry out, so you can heat those up a lot easier. So often, if it's very wet and rainy, we can actually have a lot of humid days in the summertime where we think it's going to dry, be dry and comfortable, and it really doesn't happen. And the opposite is true too. So when we get into several weeks of dry weather, that can easily promote some higher temperatures. So that goes kind of hand in hand sometimes, and it certainly did this year. Let's see. Rosemary has a couple of questions. Does a dry summer usually lead into a dry winter with little snow amounts, or is there no relation? Not really relation as far as I know. I mean, the patterns can change pretty quickly. Usually, like our weather patterns will go in periods of like 6 to 8 weeks at a time. So we'll kind of see, the fall tends to be a dry time anyway. And we tend to get most of our winters now kind of in like a 6-week stretch from late January into February or even early March. So, I'd have to go back through the kind of the climate stats and see. Maybe what we'll do, Rosemary, is we'll include something on that in our Winter Outlook webinar, so we can look that up and kind of see. But I don't think offhand there is a correlation. But we'll check it out. And she also wants to know, when is the next El Nino coming? Maybe next year, I guess. It's definitely looking like it's going to trend neutral by March and April. And from there, whether it stays neutral or turns into El Nino, we will just have to see. So possibly, maybe by late spring, early summer, but we'll have to kind of see how things go. And let's see, question from Sebastian: with La Nina likely persisting into the winter, do you think we could use the weather patterns observed over this summer as a proxy for what may happen this winter? In other words, above average temperatures, shots of cold, and heavy precipitating bursts. Yeah, I mean, I would almost look back at last winter and kind of use that as a good comparison. It seems to be about the same strength of La Nina, maybe a little bit weaker. But usually, the weak or La Ninas like we had last year tend to favor a little bit more in the way of precipitation here. And like Rodney said, it's all timing. So if we have cold air in place, we'll get the snow, but if not, we'll end up going, snow to rain or something. The stronger La Ninas, which we're not seeing, tend to push everything farther to the south. So places like Philly, DC get all the snow, and we end up just kind of dry and cold. But I don't think we see that for this winter. So my gut is just saying something similar to last winter. But Rodney, you have any comments on that?
No, Joe, I agree with what you said. I mean, I think last season is going to be a pretty good proxy for what might happen this winter. But really, you really need one good storm to for the winter to be above average. That was the case for Boston and Providence.
Yeah. Yeah, we'll kind of see. But yeah, for now, I think we're kind of thinking something similar to last winter. But we'll be, I think Rodney will be working on our outlook there for some time in October to get their webinar together. We'll get the climate crew on this one. All right, and Sebastian, as a follow-up, do you think this triple dip, the 3-year La Nina phase, which is what we're in, is contributing at all to any of the unusual weather events around the world we've seen so far this year? It's possible, and like you've noted, there's very few data points to compare this against. It's not a common occurrence. So, yeah, it's certainly possible. I mean, there's always a lot of factors that are at play. You can't just blame things on one particular pattern, but it's certainly a dominant feature on the globe. So it's quite possible, Sebastian. And I think we'll have to, again, leave it to the climate folks to kind of sort that out. But that's a good observation. Let's see. Ethan's got a question on tomorrow. So let's say, this will be a good segue into the briefing. So he's got a question about the tomorrow in our tornado study, which you can find on YouTube. We did a webinar on that a while back. SPC has a 2% risk for tornadoes. So what type of synoptic setup would be classified as tomorrow? That will be type A, a Southern Ontario closed low, Ethan, which is our most common severe weather setup. So there you go. And let's see. Yep, Jonathan says 53 inches of white gold at Boston last winter. They did pretty well. A couple of 12-foot snowstorms, 12-inch snowstorms, not 12 feet, no. So we'll see. It seems every year we kind of get the 1-foot snowstorm somewhere in our area. So we're in a pretty good track record since the 2010s. We'll see if that continues.